In this video, we are going to solve some questions on integration. The first question here is the integral of sine squared x dx. The integral of sine squared x dx. This is not a standard integral, right? We can actually reduce sine squared x to something that is easy to integrate. This is it. Sine squared x actually is 1 minus cos 2x all over 2. Okay, by trigonometry, this is true. So the integral of sine squared x dx is equal to the integral of 1 minus cos 2x all over 2 dx. If we split this integral, we'll have the integral of 1 over 2, alright, this is in brackets 1 over 2 dx minus the integral of cos 2x over 2 dx. So we have the integral of 1 over 2 dx minus the integral of cos 2x over 2 dx. Alright, what is the integral of 1 over 2 dx? 1 over 2 is a constant, so it's like saying the integral, it's like saying 1 over 2 into the integral of dx minus, I can bring 1 over 2 out from here, we're having 1 over 2 into the integral of what? Cos 2x dx. So the integral of dx is x anyways, right? So we'll be having 1 over 2x. The integral of dx is x, and x times 1 over 2 is 1 over 2x minus, we have 1 over 2, alright. What is the integral of cos 2x dx? It's straightforward. The integral of cos 2x dx is a standard integral. The rule says that the integral of cos kx dx is equal to this. If I integrate the cosine function, I will obtain the sine function. So I'll get sine kx all over k, this is the k, plus c. So the integral of cos 2x dx will now be, based on this principle, it will be what? Sine 2x all over 2, right? Is actually multiplying the 1 over 2 outside. And since the entire integral is not definite, we'll add the constant of integration to it. So if we simplify it one more time, we'll have 1 over 2x, okay, minus 1 times sine 2x is minus sine 2x. 2 times 2 is 4, plus c. And this gives the integral of sine squared x dx. Now, let us integrate sine cube x dx. That's the next question. This is how to integrate sine cube x dx. Sine cube x can actually be written as this: sine squared x times sine x. Yes, sine cube x is sine squared x times sine x. So that when they multiply together, that's sine squared x and x, will obtain sine cube x. It's like saying x to the third is equal to x to the second times x to the first. That's x cubed equal to x squared times x. That's what we are saying here. Sine squared x itself is this: 1 minus cos squared x. By trigonometry, sine squared x plus, this is it, sine squared x plus cos squared x is equal to 1. So if we make sine squared x the subject of the formula, we are going to obtain 1 minus cos squared x. And that's what we have here. So this is sine squared x, which is 1 minus cos squared x. Then sine x will remain, sine x dx. Look at this integral like this. The integral of 1 minus cos squared x times sine x dx. Picture this integral like this for a reason. See what I want to do now. Looking at this integral, this is cos s, this is cos squared x, alright? If I differentiate cos s, not cos squared x now, cos s with respect to x, I will obtain minus sine x. I can see sine x outside, just that it does not have a minus. So let's look for a way to manipulate it. I'll make a substitution. Let u be equal to cos s. Alright? If I differentiate u with respect to x, which is du dx, differentiate cos s with respect to x, that will be minus sine x. I can see sine x ds here. Can I get sine x ds from this equation? I have differentiated u with respect to x and I got this. So if I cross multiply from here, I will obtain du equal to minus sine x dx. Okay, I can see sine x ds here. It's just to remove the minus. So I can divide both sides by minus, here become plus, here become minus. This integral will now be the integral of 1 minus, remember we said let u be equal to cos s. That means cos squared s will be equal to u squared if we square both sides. Alright, so this is u squared. Okay, what is sine x ds? Sine x ds is minus du, right? So minus du times minus du, which is the same thing as saying this minus can come out. We have the minus into the integral of 1 minus u squared du. So if we integrate this now with respect to u, we have the minus is outside. Integrate 1 with respect to u, you get u, right? Then integrate minus u squared with respect to u, that will be minus u cubed all over 3. Remember the rule of integration. You add 1 to the power and divide by the sum. The integral is not definite, we'll add the constant of integration to it. Remember we said let u be equal to cos s. So we are going to make back that substitution. This is now minus, what is u? Cos s minus u is still cos s. So this one will now be cos cube s, alright, cos cube s all over 3 plus c. So we can choose to leave it this way, or if we expand the bracket, alright, if we open the bracket with the minus 1 outside, minus times cos s, that's minus cos s, minus times minus cos cube s over 3, that will be plus cos cube s over 3. So if I write the cos cube s all over 3 first, because it is positive, and this minus cos s second, that will be minus cos s plus the constant of integration. This is the integral of sine cube s dx. Look at this integral. We have to evaluate the integral of s cube log x to base e ds. S cube log s to base e ds. This log x to base e is the natural logarithm of x. The logarithm to base e means natural logarithm. So we can write this integral as the integral of s cube ln x dx. They are the same. Remember I said logarithm to base e, that is log to base e, log s to base e means ln x. Take note of this. So we can evaluate this integral using integration by parts. Integration by parts is used to evaluate the integral of a product. When integrating by parts, we make two choices. One choice for u and one choice for dv. So what do we choose as u now? There is a mnemonic that I gave that we use to choose for u and dv, and that mnemonic is LIATE. Logarithmic, inverse, algebraic, trigonometric, and exponential. So This is algebraic, x cube. Ln x is logarithmic. Logarithmic is L. It comes before algebraic, which is A. So I should choose ln x as U. You get it? Then I will choose x cubed ds as dv. I will differentiate u now with respect to x, that is du dx. Differentiate the natural logarithm function to obtain 1 over x is a standard derivative. If you differentiate ln x, you will obtain 1 over x. That is to say, the integral of 1 over x is ln x. Alright? To obtain v from here, we take the integral of both sides. So the integral of dv is v. The integral of x cubed dx, going by the principle of integration, is x to the fourth all over 4. As you add 1 to the power and then divide by that sum. So we now make use of the integration by part formula. And the formula says the integral of u dv is equal to uv minus the integral of v du. What is the integral of x cubed log x to base e? Why am I writing log x to base e? It's the same thing with this anyways. I'm supposed to write this, but no problem. We are still on point. What is u? U is ln x. What is v? X to the fourth all over 4. So we have x raised to the power 4 all over 4 ln x, right? That's the product of u and v minus the integral of what's v? The same x to the fourth all over 4 du. Okay, watch. Du dx is equal to 1 over x. So if I make du the subject of the formula here, it will be du equal to dx will multiply this, that will be 1 all over x dx, right? So du from here is what? 1 over x dx. So I'm going to write times 1 all over x dx. Let's proceed. So we have this integral is equal to x to the fourth ln x all over 4 minus, I can bring 1 over 4 out from here into the integral of what? This is x raised to the power 4 all over x. So x raised to the power 4 divided by x is x cubed dx. Okay, so this is equal to x to the fourth ln x all over 4 minus 1 over 4. What is the integral of x cubed dx? Going by the principle of integration, add 1 to the power, then divide by the entire sum of that power. That will be x raised to the power 4 all over 4, because 3 plus 1 is 4. The integral is indefinite. We add constant to it. So what is this now equal to? This is x to the fourth ln x all over 4 minus 4 times 4 is 16. So we have x to the fourth all over 16 plus c. This is the integral of x cubed ln x dx. Alright, it's as simple as this. This is the next integral to evaluate. The integral of x squared 4x squared minus 5 dx. Alright, looking at this integral, I know that the method to be applied is the method of integration by substitution. So I'm going to apply substitution here to integrate this function. Do you know why? If I look at this inner function, what is it? 4x squared minus 5. If I differentiate this 4x squared minus 5 with respect to x, I will get 8x. 8x. 2 times 4 is 8. 2 minus 1 is 1. differentiate this one to get 0. Okay, I will get 8x. What am I going to do with this 8x? I can see I'm not bothered about this 8 anyways. Don't be bothered about this 8 because 8 is just a constant. I'm concerned about this x. Can I see x outside? Yes, I can see x outside. So I want to write this integral like this. Look at it. The integral of sec squared 4x squared minus 5. This x multiplies dx, x dx. I'm correct. So look at this integral like this. So I'm going to replace this s ds with something else. So I will say let u be equal to this inner function like I said earlier, 4x squared minus 5. And if we differentiate the inner function with respect to x, we're going to obtain what? 8x. And what does this imply? That if we cross multiply, du is equal to 8x dx. Right? Okay, I can see s ds, s ds. It's just for me to remove this 8 from here. Very easy, I can do that. So I'll just write du all over 8. That's divide both sides by 8. Du all over 8 will be equal to what? S ds. So this s ds here will be replaced with du over 8. This integral is now the integral of sec squared. Everything here is u, right? We said let u be equal to 4x squared minus 5. So I'm writing u there. Then this s ds is now du over 8. Du all over 8, which is the same thing as saying if this 1 over 8 come out, we'll have 1 over 8 into the integral of what? Sec squared u du. So what is the integral of sec squared u du? The derivative of tan x is sec squared x. That means the integral of sec squared x is tan x. So when we're talking about the variable u now, if the derivative of tan u is sec squared u, then the integral of sec squared u will be what? Tan u. On this note, the integral of sec squared u du is simply tan u. And add the constant of integration to it. So remember, we said let u be equal to what? 4x squared minus 5. So this is now equal to 1 all over 8 into tan u is 4x squared minus 5. So we have 4x squared minus 5 plus c. This is the integral. Alright, let's evaluate this integral. The integral of x plus 3 all over x squared plus 6x dx. If I look at this denominator very well, I can see x squared plus 6x. And the derivative with respect to x of x squared plus 6x is 2x plus 6. That is, if I differentiate this x squared plus 6x now with respect to x, I will get 2s plus 6. Look at 2x plus 6. Can you see that s plus 3 is a factor of 2s plus 6? So what I mean by factor? If I bring 2 out from here now, I'll be having 2 in bracket s plus 3, right? So can you see that there is s plus 3 here and there is s plus 3 here as well? I'm not concerned about the 2 because 2 is a constant. So what I want to do is to make everything here at this numerator 2 in bracket s plus 3. So if I must multiply this top by 2, I must also multiply the bottom by 2 to make it equal. So this is simply equal to the integral of, okay, let me say 2 over 2 x plus 3 all over what? S squared plus 6x dx. So if I send this 2 inside, we now have 2 times x is 2x. 2 times 3 is 6. Divided by what? Let's leave this one here. You get the point? Because we don't need this one to go inside. It's only these two that needs to go inside so that it can be equal to the derivative of the bottom. That's the point. What we have here is x squared plus 6x dx. If I have a function of this form, the integral of f prime of x over f of x dx, that is, if the derivative of the bottom is equal to what is at the top, then the integral is the natural logarithm of the bottom. The derivative of x squared plus 6s is 2s plus 6. The derivative of what we have at the bottom is what is at the top. This integral is simply equal to, there's 1 over 2 there, 1 over 2 into the natural logarithm of the bottom, which is x squared plus 6x. And we add a constant of integration to it because the integral is indefinite. So this actually is the integral of this function. The integral of 1 divided by 1 minus s squared dx. What is the integral of this function? 1 over 1 minus x squared with respect to x. If I look at the denominator very well, 1 minus s squared, first of all, the derivative is 2x. So it's not even what I have at the top. So let's neglect that. Okay, see. I can write this integral as 1, the integral of 1 all over 1 minus s squared is actually 1 squared minus s squared, right? Because 1 squared is still 1. And this is a difference of 2 squares. So the principle of difference of 2 squares can be applied here. 1 squared minus s squared is 1 minus x times 1 plus x dx. So we can resolve this into partial fraction. This is not a standard integral. So we must resolve it into its component partial fractions to obtain simpler expressions that can be easily integrated. Let us resolve this expression here into partial fractions. 1 all over 1 minus x, 1 plus x equal to, the two factors at the bottom are linear factors, right? 1 minus x, 1 plus x. We are adding them 1 plus x. Since they are linear factors, we assign constants to their numerator. You can watch my video on partial fractions, okay, to understand what I'm doing here, right? So if I simplify this right hand side, I'll be having the LCM is still the same as what's here. So this LCM divided by 1 minus x, we have 1 plus x. So 1 plus x times a, that's a in bracket 1 plus x. Okay. The LCM again divided by this is 1 minus x times b, that's b 1 minus x. Alright, so if these two cancel out, I'm not working with this anymore because this is equal to this. Alright, so I'm having 1 equal to, what's left here? A in bracket 1 plus x plus b in bracket 1 minus x. So as it is solving partial fractions, at this stage we need to eliminate one of the constants, either a or b. So we can, let's say we are going to eliminate b, for example. We need a number, a value for x, that when plugged into this equation, everything here that concerns b will become 0. So what will I put here that will make everything here 0? That will not make a 0. Is 1. If I put 1 here, 1 minus 1 is 0. So everything here becomes 0. Alright. So when x is equal to 1, this is the 1 on the left hand side, is equal to, plugging 1 here, that will be 2. Alright. 2 times a is 2a. Everything here becomes 0 because 1 minus 1 is 0. And this means that a is equal to half. 1 over 2. So a is 1 half. The same way we got a, let's get b. What do we plug in for x that will make everything here equal to 0? Okay, it's going to be minus 1, all right, minus 1, because 1 minus 1 is 0. So when x equal to minus 1, we're going to obtain 1 equal to 1 minus 1 is 0, so everything is 0. Then we have b in brackets. 1 minus minus 1. There is a minus here before, and we are saying that x is minus 1. So 1 minus minus 1 is 2, and that will be 2b. So dividing both sides by 2, it means that b is still equal to 1 over 2. So a is 1 half, b is also 1 half. Therefore, this expression or this integrand, which is the compound fraction, will now be 1 all over 1 minus x, 1 plus x is now equal to a is what? A is 1 half. So we have 1 all over 2 all over 1 minus x, 1 minus x. B is still 1 over 2, 1 all over 2 divided by 1 plus x, 1 minus x. B is still 1 over 2, 1 all over 2 divided by 1 plus x. So it's very straightforward. You know, this is the same thing as this. So if I say the integral of this dx, I'm saying the integral of this dx plus the integral of this dx. You get the point. So let me push the 1 half outside. 1 all over 2 into the integral of 1 all over 1 minus x dx, plus if I push this one outside, it's still 1 over 2, so the integral of 1 all over 1 plus x dx. Okay, so 1 over 2. I said something just now. If the derivative of the bottom is the numerator, then the integral is the natural logarithm of the bottom. All right. In this case now, we have 1 plus x at the bottom. Differentiate 1 plus x with respect to x, that's 1, right? And that's exactly what we have at the top. But in this case, it is 1 minus x at the bottom. Differentiate 1 minus x with respect to x is going to be minus 1, because this x here is negative. But we are having plus 1 at the top. So is there a way we can make this plus 1 negative? Of course we can. So this is what we are going to do. If I multiply this by minus, for example, I must bring a minus outside, so that minus times minus will give me a plus. It's as if nothing is, it's as if I didn't multiply through by minus. Divided by 1 minus x dx plus 1 over 2 into the integral of 1 all over 1 plus x dx. All right, so the derivative of the bottom now is the numerator for both. It is simply 1 over 2, okay, minus 1 over 2 into the natural logarithm of 1 minus x plus 1 over 2 into the natural logarithm of 1 plus x plus the constant of integration. Okay, in this very question, this is not the way the answer was left in the option. So I want to reduce this, or should I say simplify this. Okay, this is correct anyways, but let's see another way of simplifying it using the law of logarithm. 1 over 2 is common to both, so if I bring 1 over 2 out, this one is positive, this one is negative. So if I write the one that is positive first, meaning 1 plus x, and this one that is negative, minus ln 1 minus x plus c. What's this equal to? Now, there's a minus in between them. The law of logarithm that will help us to simplify this is the law of logarithm that says that log a to base b minus log c to base b where they have the same base, is simply equal to the logarithm of a all over c to base b. There's a minus and the two of them have the same base, so you just say a divided by c. If it were to be a plus, then we'll multiply a and c. On this note, this becomes 1 all over 2 into the natural logarithm of 1 over x, 1 plus x divided by 1 minus x plus c. So we can leave it this way. Or if we apply another law of logarithm, this 1 over 2 here will stand here as a power of 1 plus x all over 1 minus x. Alright, so whichever one is correct. So this is it. Any of these two is the integral to that particular question. Let us evaluate the integral of s squared cos s cubed dx. Looking at this integrand, I can see cos s cubed. Okay. If I differentiate s cubed with respect to x, what will I get? I will get 3x squared, right? 3x squared. 3x squared. Forget about the 3 because it's a constant. What can you see? X squared. In the integrand, does x squared appear? Yes. There is x squared here. So look at this integral like this. The integral of cos s cubed times this s squared dx times s squared dx. So we are going to totally replace this s squared dx with something else. Watch. Let u be equal to s cubed. I am performing integration by substitution right now. If I differentiate u with respect to x, I'll get 3s squared. Okay, you know how I got here? Du dx is equal to 3s squared. So if I cross multiply, du be equal to 3s squared dx. S squared dx is here, and I can see it here also. It's just for me to remove this 3 from here, so that it will just be s squared dx completely. So if I remove that 3 from there, it means that we're having du all over 3, that's dividing both sides by 3, equal to s squared dx. So s squared dx will now be du all over 3. So therefore, the integral of cos s cubed into s squared dx, as I've made it to be, is equal to integral of cos, what's s cubed? S cubed is u, alright, cos u. What's s squared dx? Du over 3. Du all over 3. I want to bring that 3 out as 1 over 3. Am I right? Yes. So that du times 1 is du all over 3. So what is the integral of cos u? Integrating cos u with respect to u will produce sin u. Because if you differentiate sin u with respect to u, you will get cos. Differentiate the sine function to get the cosine. Integrate the cosine to get the sine. So we have 1 over 3 sin u. Okay, u right plus c. What is u? Remember that u is something. U is s cubed. So we just say 1 all over 3 sin s cubed plus c. So this is the integral. What is the integral of dx upon the square root of 4x minus 7? We can write the integral as the integral of 1 all over the square root of 4x minus 7 dx. So this square root is actually a power of 1 over 2. That is 1 all over 4x minus 7 to the power of 1 half, 1 over 2. And this can be written as the integral of 4x minus 7. Since we are inverting it, the power becomes negative 1 half. We can actually integrate using method of substitution. This is 4x minus 7. Okay, if I differentiate 4x minus 7, I will obtain 4. That is, if I differentiate it with respect to x. Let u be equal to that 4x minus 7, so that du will be equal to 4 ds, right? Differentiate u with respect to x, that will be 4. So du ds equal to 4, that means du is equal to 4 dx. If we cross multiply, we'll get this. I can see dx here. There is no other constant attached, so I can eliminate this 4 from here by simply dividing both sides by 4. I will obtain du all over 4 equal to what? Dx. So ds now is du over 4. This integral can be written like this now. The integral of 4x minus 7 is u to the power of minus 1 all over 2. ds is du over 4. So if 1 over 4 comes out, we have 1 over 4 into the integral of u to the power of minus 1 over 2 du. So applying the rule of integration on this, we have 1 all over 4. This is u to the power of minus 1 all over 2 plus 1 divided by minus 1 over 2 plus 1 plus the constant of integration. 1 over 4 all into minus half plus 1 is half plus half. The same thing there, plus half. These brackets will now reduce to 1 over 4 into 2 all over 1. The 2 multiply this one on top. 2 here is 1, 2 here is 2. So we are having 1 over 2. Remember that u is what? 4x minus 7. So we have 4x minus 7 to the power of 1 over 2. So finally, we can leave it in form of the square root. 1 over 2. This is the square root of 4x minus 7 plus c. This is the integral. Now, let's integrate this. The integral of 3x plus 1 divided by 2x minus 3 dx. Okay, this is a rational expression. By rational, I mean it's a fraction. So both of them have the same degree. By degree, I mean the highest power of x. The highest power of x here is 1, and of x here is also 1. So let's break it down using polynomial long division. We are going to obtain the quotient, the remainder. Watch. I'm dividing this by this. So this is the dividend. 3s plus 1. And this is what we are using to divide. It is called the divisor. 2x minus 3. So 3x divided by 2x, 3x all over 2x is 3 over 2, right? 3 over 2, that will be here. 2x times 3 over 2, that will still give us the 3x. Minus 3 times 3 over 2, that's minus 9 all over 2. I'll subtract. Alright. 3x minus 3x is 0. 1 minus 9 over 2. That's 1 plus 9 over 2 because minus is a plus. So 1 plus 9 all over 2, what would that be? 2 times 1 is 2. 2 plus 9 is 11. 11 all over 2. Alright. So this is the remainder. I can't divide further. So this means that I can restate this expression as this. The integral of, what is the quotient? 3 over 2. 3 over 2 plus, what is the remainder? 11 over 2. 11 over 2 divided by 2x minus 3. So I want to write it like this. This is simple. If we split it to be integral of 3 over 2 dx, right, plus, okay, if I'm taking the integral of this, I want to bring 11 over 2 out because it's a constant. 11 over 2 into the integral of, we now have 1 all over 2x minus 3 dx. Okay, if I integrate this, I'm going to obtain 3 over 2x plus, watch, if I differentiate 2x minus 3, what will I get? I'll get 2, right? I'll get 2. Okay, at the numerator I have 1. So to get 2 at the numerator is just to multiply 1 by 2, right? If I multiply 1 by 2 now, here will now be 2. So if I must multiply the top by 2, I must also multiply the bottom by 2. That means I should also say 2s minus 3 times 2. But I want to bring that 2 outside as 1 all over 2. I don't need it inside. Okay, this is what I need inside because it is the derivative of 2x minus 3. So if I must multiply that 1 by 2 so as to make the numerator 2, I must also multiply the bottom by 2 so that if I say 2 divided by 2, it will cancel out. But I don't need this 2 inside, that's why I'm bringing it outside. So we now have 11 times 1 is 11, 2 times 2 is 4. The integral of 2 all over 2x minus 3 dx is the natural logarithm of 2x minus 3. Then add a constant of integration to it. It is simple. Differentiate the bottom to get the top. That means the integral is the ln, the natural logarithm of the bottom. This is the integral of this function. What is the integral of y e to the power of y squared dy? The independent variable here is y. This time around is not x, is y. So we perform the integration. And the method of integration to be applied here is the method of substitution. This is y times e to the power of y squared. E is raised to the power of y squared. So if I look at y squared, look at this y squared now, the inner function of this e to the power of y squared. If I differentiate the y squared with respect to y, I will get 2y, right? 2y. Don't be concerned about the 2. 2 is a constant. Can I see y anywhere here? Yes, I can see y. So look at this integral like this. The integral of e to the power of y squared times y dy. Look at it this way. Times y dy. Times y times dy. Alright? So I'll say let u be equal to y squared. So if I differentiate 2 with respect to y, I will get 2y. Which means that if I cross multiply, the u is equal to 2y dy, right? Here we have y dy, but I'm seeing 2y dy here. Let me remove the 2 to make everything here the same. That means I'll have to divide both sides by 2. So that the u over 2 will be equal to y dy. Perfect. So this integral, I want to restate it now in terms of u as the integral of e to the power of u. Remember we said let u be equal to y squared. So I'm writing u now in place of y squared. Then y dy is now du all over 2. I will bring 1 over 2 outside. We now have u e to the power of u du. So this is the integral of the exponential function. Integrate e to the power of u du, it is still e to the power of u. So remember that u is y squared. Therefore, the integral of e to the power of y e to the power of y squared dy, right, is equal to this. U is y squared. So we have 1/2 into e to the power of y squared plus c.